Hi everyone. Today we are going to talk about key factors influencing GDP, and we are Group 3. I'm Christiana Chen. These are our contexts. We will divide it into 4 parts. The first part is project proposal. The second part is descriptive analytics. The third part is predictive analytics, and the last part is conclusion. Let us see the project proposal, part 1. So our problem statement is, what are the key factors influencing the GDP? What is GDP? GDP is a crucial indicator of a country's economic health, and it is influenced by various factors that interact dynamically to shape the economic performance of a country over time. And this is the formula of GDP. GDP contains C, consumption expenditure, I, investment, G, government expenditure, and X minus M, which means next export. So for the data preparing part, we're using the data from BMI, and the data set name will be BMI Economic Data Annual from 2003 to 2024. And these are the factors we used. First of all, our data contains 10 countries' data, and we use like 20 target variables for it.
Based on the formula of GDP influencing factors, we conducted a literature review. The following studies were identified as relevant references for our research question. Eric's research focuses on consumption, emphasizing it as the main driver of GDP. Deblon-Norris highlights the significance of investment, identifying it as a critical factor driving economic growth, while Blanchard and Lee concentrate on government expenditure. Moreover, Caraduel and Law provide theoretical support for the impact of exports and imports on economic development. Additionally, we refer to the studies by Hanashek and Holzman as well as Ferris, which focus on demographic influences on GDP. This literature review forms a strong theoretical foundation for our exploration of GDP influencing factors. Next, let's focus on the descriptive analysis section.
Okay, let's talk about part 2, descriptive analytics. Our team found the appropriate data on the database website, and we use Excel to calculate the most suitable data for the whole analysis models. And also at the same time, we deleted the columns with more than 50% non-values and convert the values to appropriate units of measurements. The third part is we normalize the data types from all the different types to the none. And we use the pair functions to observe the linear relationship between the data columns in the data frame. You can see in the pictures of the right down sides. And we use the scatter plot to use it between like GDP and 9 other variables to help us better understand the relationship and distribution between those two. And we could find that the government consumption billion was the most appropriate for linear relationship. Also, we transform all the things in the heat map, and you can see in the map that if there are like really like positive correlations, there will be 1.0, so that will be red one, and if it's really like negative correlations, that will be the purple one. And last, we also view the distribution using the k-means clustering method and set to like 3 or 4 or 5 clusters like to represent Lee.
Now let's turn to part 3, predictive analytics. Let's start with linear regression. The model is built to predict national GDP and analyze the impact of variables. It achieved an impressive R-square of 99% on the training set and performed well on the test set with a test MSE of 165 million. Significant variables include the government consumption, the household spending, and the political risk. Next, we apply ridge regression to reduce overfitting by applying L to regularization, which penalizes large coefficient. Cross-validation is used to select the optimal lambda value, ensuring a balance between bias and variance. The model achieved a test R-square of 98.6%, slightly outperformed linear regression, with a tax MSE of 693 billion. The result is good. And lasso regression was applied to perform feature selection using L1 regularization. This simplified the model, transformed less important coefficient to zero. It achieved a high trend R-square of 99.17%. The R-square dropped to 79.87% with a higher test MSE of 997 billion. The gap between trend and test performance suggests overfitting, potentially due to removing too many predictors, leading to higher residuals.
Hi, I'm Fen. Today, let's talk about the regression tree model and the bug models. So, a regression tree split the data into subsets based on the features that minimize the prediction errors, using a hierarchical recursive process to model nonlinear relationship and make predictions. From this result, we can see the performance. We think the most important variable is the imports. Second is total household spending and the industrial index. The number of the terminal nodes is 5 and test error is 269 billion, so it's quite large. And from this, we can see two types of regression trees. We first split it by the imports with the value below the 1 billion and 863 thousands. The lowered move to the left branch and equal or above move to the right. Then the left branch we split by the total household spending into 3 different value level, and the right branch we split it by the industrial index and have 2 leaves. So, and from this graph shows the cross-validated error for different tree size, helping identify the optimal tree size to balance the accuracy and complexities. And we can see the optimal tree size is 5. And then we come to the bugging model. Bugging is an example learning methods that improve the model accuracy and reduce the overfitting by training multiple models on different bootstrapped subsets of the data and combining their predictions. So we can see the performance. Examine the variance is 99% and text MCA is 51 billions. The optimal test MCA is 46 billions with the entry is 1,000. And from this important test, we can see the total household spending is the most important. And thank you. That's all.
Hi. So now let's talk about random forest and neural network models. So first, we use the random forest model to predict GDP. The advantages of random forest are its robustness and easy interpretabilities. By building multiple decision tree and performing integrated predictions, random forests can effectively reduce the overfitting problems that may occur in a single model. So in our studies, the random forest model achieved good performance, explaining more than 98.81% of the variable changes, showing extremely high fit abilities. At the same time, the test MCE of this model is 83,238,588,844. So, and from the scatter plot of predicted value and actual values, you can see that most of the points are closely distributed near the red diagonal line, which shows that the model's prediction results are very close to the actual values. In addition, a highlight of random forest is that it can help us to identify the most important feature for the GDP predictions. So through the output of variant plot and importance functions, we found that total household spending billion is the variable that contributes the most to GDP predictions. And it also performs well in the improving node purity and the reducing errors. So this part of data indicates that increasing household spending may be the key to promoting GDP growth. And next, let's talk about neural network. So neural networks are good at capturing nonlinear and complex data relationship by simulating the connection relationship of human brain neurons. So we use a two hidden layers neural network model. So with 5 nodes in the first layer and 3 nodes in the second layers. And here the blue number is the size of the weight which determines the specific impact of the feature on GDP. And however, one disadvantage of neural network is that they are less interpretable. So it is hard for us to directly interpret features that have the greatest impact on GDP prediction directly from this weight. And the text MSE of this model is 38,248,636,207. So which is smaller than the random forest. And this shows that the neural network are excellent in capturing complex nonlinear relationships in data. Combining with the result of data error equal to 0, it can be seen that this neural network model can not only run stably, but also provide reliable prediction on other new data.
In the KNN model, I splitted the data into a 1:4 ratio of the test and train. After changing the k-value and retraining with cross-validation, I noticed that the MSE only changed slightly. This plot shows the model of k-values of 3, 5, and 10. It seems like the MSE is staying a little over 55,000. However, there may be some kind of overfitting risk. For the boosted tree model, to avoid overfitting, I tried different depths like 3 and 4, not over than 5, and adjusted the number of entries. In the end, the model showed that how much each variable influenced the GDP billion. On this page, the feature importance graph illustrates how each feature contributes to the model, while the scatter plot shows the difference between the predicted and actual values, along with the residual plot. Finally, we come to the summary section. We agreed that the boosted tree model does the best job of predicting the target variable, GDP billion, especially after addressing the overfitting issue. Members of the group noticed that, compared with the data in classroom labs, it was really difficult to find, clean, and standardize the data from the websites. We also faced with large and complex databases. And for this kind of data, conventional and simpler models, such as the previous ones in this set of experiments, have limited predictive power. When using complex models, overfitting and other problems have to be considered. This page shows the references our group has made. And that's all. Thank you for your listening. If you have any question, please feel free to ask.